Good afternoon, good morning, everyone. Sorry for the little delay starting. First of all, I would like to say that we would like to record this session to share in the project YouTube social network. Okay. My name is Alicia Martinez Garcia, and with I am from the Andalusia Health Service. And with Anil from SRDC and Miriam from Atos, we are going to present this virtual session called FAIR4Health demonstration. The objective of this session is to share with you the functionalities of the FAIR4Health solution, the solution designed and developed in the context of the FAIR4Health project. Also, the presentation is going to be performed by us, that are 3 researchers of the project. Today, we have performed the FAIR4Health Final General Assembly. Here, we are all the consortium. Some of them are here in person with us, and other us is connected in this session. The objective of this session is to continue encouraging the European Union health research community to verify, share, and reuse their health data sets through the dissemination of the FAIR4Health results. And other of our objectives is to identify future collaboration in the use of the FAIR principles in health. This is the outline we are going to review. Firstly, I'm going to do an introduction. I'm going to present the verification workflow designed in the context of this project. I'm going to present in a high level the FAIR4Health architecture. Below, Anil will present the functionality of the verification tools, that are the data curation tool and the data privacy tool. And Miriam and Anil will present the functionalities of the FAIR4Health platform, that at this moment include 2 use cases, one related to association patterns, or intelligence artificial algorithms, and other related to prediction models. And for us, the more important part of the demonstration is the last one, because we would like to hear you, to discuss with you, and to know if you are interested to work with our solution. Okay, first of all, I'm not sure if all the audience know what are the FAIR principles. The FAIR principles were formally published in 2016, and the aim is to transform, to adapt the raw data to obtain findable, accessible, interoperable, and reusable data. These principles was proposed to be used with different kind of data, not only with health data. And in FAIR4Health project, we are working with the FAIR principles in the context of health data. This project started on December 2018 and finished next week, this month, in November 2021. This is the reason today we are performing the final general assembly. The main objective of the project has been to facilitate and encourage the European Union health research community to use the FAIR principles to share and reuse the data set derived from publicly funded research initiatives through the demonstration of the potential impact that such a strategy will have on health outcome and health research. The project has been coordinated by the Andalusian Health Service. The main researcher is Carlos Luis Parra Calderón. And we are 17 partners from different disciplines. We have worked together with research organization, experts in data management, experts in health informatics, software developers, and so on. The first step, one of the first main steps in the project was to define the verification workflow, allow us to use, collect raw data and transform to comply with the FAIR principles. Using the GoFAIR verification process as a basis, we review this process that can be applied with any kind of data, not only health data, and we review the special issues, characteristics, or requirements that the health data can introduce of this workflow. So in this context, we designed the verification workflow for health data. We extend the GoFAIR process to cover the curation and the validation of the data, the identification and anonymization, the version, the index, because we identify that in the context of health data, we need to cover this kind of tasks. For example, the anonymization or the identification is very important because taking into account the sensitive nature of this kind of data. This workflow was published, and here you are the reference if you would like to go in depth. By other hand, taking into account this verification workflow, we design and we have developed and validated an architecture. This architecture, by one hand, developed the verification tools that being possible in a practical way, the verification workflow. By other hand, we designed and developed and validates a FAIR4Health platform that uses the FAIR data that the verification tools generate to demonstrate the potential that we can obtain if we work with FAIR data. In this slide, you can see the architecture, the technical architecture that we have in our projects. The data curation tool and the data privacy tool must be running in the data owner to cover the privacy restriction of this kind of data. We identify the needs that transform the data raw to FAIR in the data owner facility. When we obtain the FAIR data, this is registered in a repository, and sorry, someone has opened the. One second, because we have, okay. The FAIR data is shared with the platform. In our case, in our experience, we use this data to generate models, to generate patterns with the data. Each clinical site generates a model with their own data this model, not the data, is shared with the central platform that join all the models to have a model that take into account the data from the different clinical sites. Here you are, the 6 clinical partners that has been involved in FAIR4Health, the Andalusian Health Service, UNIS, IACS, UCC, and the University of Porto, and EPVV that didn't need to install the verification tools because they cannot contribute to with retrospective data to the project. When we generate the models, we tested this model in a prospective study. The prospective study was performed in SAS and EPVV. So at this moment, Anil Sinasi from SRDC is going to continue showing the functionality that the verification tools can offer to the scientific community.
Thank you, Alicia. I hope my voice is going to the attendees. After showing some slides, I'm going to make a demonstration of the tools with some mock data that we prepared, but I'm going to do it live with the tools. So we first in the project designed the verification workflow, and then we implemented this workflow with software to end up with FAIR data using the already available research and healthcare data of our clinical partners. So our verification workflow is designed around HL7 FAIR. So we utilize HL7 FAIR to come up with FAIR data. That's why we first install a FAIR repository on each data owner, and then run first the data curation tool, and then on top of it the data privacy tool to end up with FAIR data. These tools actually implement on behind the scene, implement the requirements of this workflow, but we only have, let's say, two tools. We are only using 2 tools covering all the steps of this verification workflow, because FAIR already inherently provides some functionality to support some of these steps. And we also use the FAIR profiling to come up with a common data model so that we shape every existing data from the partners into the same, let's say, we convert into the same shape. Next slide, please. So the first tool is the data curation tool. It's a standalone desktop application which can be downloaded and run on the major operating systems, Windows, macOS, and Linux. The ultimate aim is to map and transform your existing data to HL7 FAIR. For this reason, to use this tool, we need a FAIR endpoint so that this tool is going to communicate and put the data in. For that one, we used OnFire.io. That's another open source FAIR repository. And in our GitHub repository for FAIR4Health, we provide the OnFire already installed with the FAIR4Health profiles. And this tool can now read from CSV files, Excel files, and from PostgreSQL databases. And as I said, it's also open source. You can visit the GitHub page for FAIR4Health and look at the details. I think I can now share my screen. Right? Yes. Okay. Okay, so I hope my screen is visible now. Okay. The first thing is that the on FAIR repository that I'm going to run. So this is the folder that
You can see the...
yeah, nice. This is the folder that you can see when you download from the GitHub releases. And I just based on my operating system, since I'm on Windows, I'm double clicking the start on FAIR button, and I'm going to wait a little so that the repository deploys the FAIR profiles and runs the repository. So this is a kind of a health data repository, I can say. For demonstration purposes, this is now a double-click deployment. But of course, for production, this could be distributed over an infrastructure inside your hospitals or research institutes. It will not take long. I wanted to show this because this is, I mean, there is nothing pre-installed now. This is a bare live demonstration. Yes, and now it says that, okay, now the service, this FAIR API, is available at port 8282 on my local computer, and I already downloaded the data curation tool and data privacy tool. It's available on GitHub, as I shared the links. So data curation tool, I run it. It's a desktop application, and I don't know whether I can take this down. Okay. Yes. So when we run the tool, it shows some information about how to use the tool. There are different steps. The first thing, so I'm when I start the curation. So as I mentioned, in order to use this tool, we need a FAIR API. So since I deployed something to my local computer, this is the API that I have. I verify, and it's verified. Okay, this is a valid FAIR endpoint. I can also add a terminology server to this. This means if I want to translate some codes, for example, if you use codes for your local in your local hospital for diagnosis, for example, and if you want to convert it to ICD-10, then we need some mapping, the translation service. So this is an example provided by Atos. I verify it. It's again a FAIR endpoint, by the way. It's verified. Then I click next, and this this screen comes up. This says, okay, first thing, we are going to connect our data source. As I mentioned, it could be Excel files or a relational database. Here I have some mock data in Excel files. That's why I'm going to browse my computer. And for demonstration purposes, I have different Excel files for each entities, like patients, conditions, encounters, observations. But they could all be in the same Excel sheet in different sheets, of course. So I loaded my files, and then I click next. Now the tool communicates with the FAIR endpoint automatically, and it retrieves which profiles, which formats are supported by this FAIR repository. So this is actually an ETL tool, extract, transform, load, but specialized for HS7 FAIR. That's why think that in general ETL software, it's common to map from left to right, but this time we employed a different approach, that we are showing the FAIR resources on the left, because we want to fill in these resources with whatever we have in our source data. I'm not going to do all the mappings, but I'm going to show you some examples. Then I'm going to load a already configured mapping. I'm going to make an example for patient. For example, this is the patient Excel file. I have only one sheet. And as I can see here, there are only 4 columns. Identifier of the patient, a gender, country, and birth date. Here I can have a look at the snapshot of the file. This is my source file. And on the left-hand side, these are the resources supported by the FAIR repository that I point. And these are the profiles supported by the repository. So I select my patient for FAIR4Health. So, and again, I'm only showing the major features of the tool, not going in details, because there are lots of, as you can see, to ease your job while doing the mapping. So for this one, I'm only going to show the mandatory files on the profile. I am mapping the patient ID, so I'm putting the patient ID both into the ID field and identifier value field. So this means that using this tool requires a knowledge of HS7 FAIR, because we are mapping to this standard. And I match the attribute. Then gender and gender. I match the attribute, but let's see the snapshot of data. The gender field, it's written like male, female, but in our profile, we accept, let's say, administrative gender, the value set from HS7. So, or this could be in Spanish, not male, female, but Spanish, male, female, or your own languages, or some other codes. For example, 1 for males, 2 for females. So we need to translate these codes. We can do it here. So of course, this means these should be already available inside the terminology server that we point. For example, we have here SAS gender and HS7. These are standard ones, administrative gender. And I say, okay, while doing the translation, I'm going to map from SAS gender codes to HS7's gender codes. And let me map also the country. I'm matching each attribute here, as you can see, and the birth date. And I can also indicate the data type, by the way, while doing the mapping. And I match the attribute. And then I add the mapping. So this means for one entity, I finished my mapping. And I will continue for each entity that I have in my files, like the conditions, laboratory tests, medications, observations, whatever I have. And I'm going to map them to the corresponding resources. Like, let me just show condition. We can map condition to FAIR condition resource. And the same thing, I'm going to match the IDs. Let me match the IDs, and I'm going to match the patient ID. It's the subject. So I don't want to do all of it, but I'm going to do it and add the mapping. So let me do it, for example. And once I'm finished, they're all here. I can edit, delete, do whatever I want with these mappings. When I click next, it says, okay, now it's time to validate. So this means maybe something is wrong with my data or with my mappings. I can see it here. Let's validate this one. I don't know whether, yeah, it has some problems for the condition. And probably it's okay for the patient. Yes, we will see.
Sorry, Anil.
Yes.
In the mean, we have a question in the chat. If you agree, I can read.
Yes, of course.
It is possible, it's from Toral Kirsten. Thank you very much for your interest. It is possible to automate the ETL process by using the specified metadata mapping?
Automate means run. Does that mean running this automatically from time to time, for example, to retrieve the new data? If that's the question, not yet. Let's say this doesn't work like an engine right now, but it's one of the first items for the future work. I don't know whether I can see the questions myself.
Here, these two,
here.
the chat. Yeah.
Okay. Yeah.
In any case, please, if someone could open the microphone and speak with us, we don't have problems. Okay? We are totally.
Yeah, that's okay, ma'am. I have a question, sir, if you don't mind.
Yes, shoot.
Yeah. I assume that your engine is mapping the simple EMR, raw data to the FAIR resources, right?
Yes, we are mapping into to the fields of FAIR resources.
To the field of FAIR resources, yeah. It's stored in where? And either they are storing the result, the FAIR resources to somewhere, to the database or somewhere else, or
it's so initially I started a FAIR repository. So these files will not yet, but when I finish the process, they are going to be persisted in this repository.
Yeah, they mean you mean they are pushing the data, the result to the FAIR to that repository, right?
Yes, pushing the data to a FAIR repository.
The input data should be the raw EMR data, right?
Sorry, can you repeat?
The input data should be the raw EMR data, simple EMR data, right?
Oh, yeah. Whatever you want. It could be the raw EMR data or some results of some research. Something can be mapped to FAIR resources.
Yeah, I mean the main objective of this project, I assume that you wanted to map the simple EMR data to the FAIR resources and store the result in somewhere like you're saying the FAIR repository, right?
Yes.
Yeah, that is the main objective, right?
Yeah, that's one of the main objectives.
That is one of the main objectives. Yeah, okay. So the result that you are storing, like the FAIR repository there, it is publicly available or it is your local? You created your own or it is somewhere public server there?
No, no. In the project, we all have our own repositories at each clinical institute, so they are not accessible outside.
No, I mean the result that you are storing, that you are said in the FAIR repository. So that the FAIR repository is the public available somewhere, or it is your own created?
It's open. It's on GitHub actually. You can download and just run it on your own local computer.
No. Of course. I'm asking that the resulting repository, that is the public available, or it is your own personal? It should be available on the public on the local machines. Like the Happy FAIR server is available. It is a free repository, right? Free FAIR server. So the people are pushing the data there. The FAIR resources there.
No, it's not public. It's not. Our objective was not make it public. Only specific for the institute itself.
Yeah. The second, does your your converter is capable to convert the HL7 version 2 messages to the FAIR resources and store the results somewhere like this, or only simple EMR data?
Can you please repeat? Sorry.
Your converter is capable to map the data which is stored in. You said the input data should be simple EMR data. Can we use the input data as the HL7 version 2 message?
I didn't get the. Is it also what? Maybe it's better for me if you can write it down.
Yeah, I can write it. You assume that your input data set should be the simple EMR data, right?
I cannot because of the. I think because of the saloon here, I cannot understand the word. Maybe it's better if you can write the question.
I assume that the input should be simple EMR data set, and output would be FAIR resources.
We
Right?
we have to hear you.
Yeah,
Please, could you write in the chat, please? Because we
Yes,
cannot
I
hear you well.
now I see the question. Yes,
Yeah.
that the output would be the FAIR resources. Yes.
Again, I use input.
So I think I can continue. And if you have questions, just write down and I'm going to try to answer them. Okay. So here, as you can see, my mapping is problematic. It says, let's say, well, a codable concept is required. The code field should be filled if you want to create condition resources. So this is an error. I'm going back so I can fix the mapping, but I'm just going to go very back and import an already successful mapping. By the way, I can import and export my mapping configurations. So here the mappings are performed for the conditions, for the encounters, medications, observations, patient, lab observations, and another observation for smoking status. So in the end, I hit the validation. Now all the data, all my data on my files are being validated against the profiles of the FAIR repository, and they are all okay. Now I can continue and hit the transform button. When I hit the transform button, the FAIR resources will be created and pushed into the FAIR API that I provided to this tool. While doing this, I can select, of course, an author and a license. I'm just selecting one. And data is now being pushed to the FAIR repository. So since this is an API, I cannot show you from a graphical user interface, but I can only, okay. I can only show you from another tool that the system is populated. So there were 0 patients, but now I'm asking again. So now there are 732 patients, and for example, how many conditions? Well, some hundreds of conditions. Yes, no, you cannot use version 2 messages right now, but there's something in our agenda. Yeah, we identified it as a to-do in our future work.
Exactly. If I'm honest, I'm really surprised because today in our last final meeting, identified that one of the future improvements that we have on mind is cover the information from Health Level 7 version 2 standard.
Yeah, actually, currently I'm working on the project like this. That's why I'm asking. I'm quite worried about this. That's why I'm stuck in my project.
Maybe before going to the other tool, I can show the GitHub page for the data creation tool, where you can see the source code, some information, and also the user guides, even the video guides and the documented user guides to see how to use the tool. So now we have our FAIR resources covering some steps of the verification workflow, because behind the scenes, the tool creates some other also resources, for example, provenance or for data set management. Some other resources are also created behind the scene to meet the challenges of the verification workflow. And now I am going to use the data privacy tool to apply some de-identification on the FAIR resources. So that's another desktop application. I'm not going to go back to the presentation. I had some information, but okay, I will just continue with the demonstration. So this is another open source tool, another desktop application, very similar technology, but this time again, we need a FAIR repository, because the ultimate aim of this tool is to apply the identification on the FAIR resources. So again, this tool requires a FAIR endpoint. And this is more, this also on top of FAIR knowledge, this tool requires a little bit about privacy algorithms also, because we are going to see some terminology related with the de-identification of data sets. Okay. I'm going to look at the questions maybe later.
Okay.
Okay. So when I start, again, I can only continue by verifying a FAIR endpoint. I verify it. It's running on my local system. I just curated, pushed some FAIR resources. And now I'm going to apply some simple configuration, not go into the deeper details of the identification thing, because this tool can not only apply single functions, the identification functions to FAIR attributes, but also can do some de-identification anonymization on the whole data set, like the K anonymity or L diversity parameters can be taken into account while doing the while running on the FAIR repository. So just for as an example, I'm going to de-identify something on the patient. Well, we already don't have much data here, but we know that we have gender and birth date. These are the terms, as I said, that, so since this is an expert system, I mean, the user is expected to know the terms like the quasi-identifier or sensitive or insensitive attributes. So I know that gender and birth date are quasi-identifiers, which means they are not directly identifying an individual, but if we use them together, we can identify, we have the potential to identify an individual. So of course, we also have identifiers, but I'm not going to the details. I'll just show this one here. And maybe something about the sensitive attributes. Let's say a condition code may be too sensitive. For example, maybe it could be used to identify someone. I don't know. So if it's a very, very specific condition code, and maybe in your area only one person has it, then you can identify the person. So let's say this is a sensitive attribute. Here, for each resource, I can select the attributes, whether they are identifier, quasi-identifiers, sensitive or insensitive, and then I hit next. Now, for example, for the patient, I see that on the quasi-identifiers, I can apply some algorithms. For example, for the gender, I can, here you see, I can only apply substitution or pass-through. So these algorithms are also suggested based on the type of the FAIR attribute that we select. I'm going to just pass through this gender, and maybe I can apply some generalization on the date, birth date. For example, the birth date are day, month, year, but for my purposes, maybe it's enough to only keep the year. So I can say that, okay, if I'm applying generalization and I want to keep the years. So for the sensitive attributes, condition, and I know that I selected condition code as a sensitive attribute. So I can say that I can apply K anonymity and L diversity for these fields, but these are working on the whole data set. And I can also apply something called, if there are very rare values for some fields, I can apply a configuration so that I replace them, or I just delete them if they are very rare, if there's a privacy risk when they are seen on the data set. So I can configure them all here. I will not do it now, but I have the now configuration for patient, let's say. Patient fields. And I'm going to show that now in the repository. Sorry for this one, but this is the only interface that I can show. The resources, the JSON serialization here. You see, this is the patient, and this is the gender, and this is the birth date, the full year, month, and day. Now I'm going to click next. I'm going to apply the identification algorithms that I selected. Now it's okay, but not yet pushed back into the repository. I can save them now. I can save them as new FAIR resource instances, or I can overwrite the existing ones. It's my choice. I'm overwriting now. Waiting. Yeah, it took some time, but yeah, maybe something wrong with my configuration, or by the way, it's also important to think about the FAIR profiles. I mean, it's the job of the user. For example, if I eliminate something which is required by the profiles, then it will not be accepted by the FAIR repository itself. So that's probably something like that. And let me check whether it worked or not. Probably not, but yeah, FAIR repository had an issue. Yes, FAIR repository had an issue about my connections. Since I am now using my local computer for the Mongo database, yes, Mongo database is creating. Well, these things happen in live demonstrations. Sorry. I will run in the backend, but I will continue my demonstration. So the tool in the end is writing back the de-identified FAIR resources, again conforming to the profiles that we used in the repository on our configuration. It's the user's job to, let's say, configure all this K anonymity and L diversity things and apply the algorithms on each FAIR attribute field. And this was actually, this was all from my demonstration of these two verification tools.
Thank you, Anil. We have a last question. A user asked, should your tools provide any data analytics on these resources?
No.
At this moment, no, but it's a good point to take into account in future improvements. Thank you. Yeah.
I have another question, ma'am. Sir, I have a question.
Yes,
Hello?
go ahead.
Yeah, the server that you created there, I mean, where you are storing the FAIR resources, what type of server? I mean, when they generate the result in the FAIR, I mean, when they take the input data is the raw data and convert into the FAIR resources. So the FAIR resources, you say it should be stored in the resulting server, right?
Yes.
The resulting server is what? I mean, that is the database or something else?
I mean, since this is a standard, we just use a repository which implements the standard. Maybe you heard of Happy FAIR?
Yeah, Happy FAIR, yes.
Yeah, it could be used, but we use another one on FAIR.io.
FAIR.io.
Yeah, here, let me show. It's also open source, by the way.
Yeah.
So this is the repository that we are using. You can see it also on GitHub.
No, so the result that you created there right now, when you click and they generate the FAIR resources there, so they push to this server, right?
Yes.
So this server is already available public, right?
What do you mean by public?
I mean, it is free, like the Happy FAIR server is available publicly, right?
Yes.
Everyone
yes.
can use it. So
yes.
this server can also use anyone, right?
You mean the software or the
No,
data?
I mean this. No, this. No, I mean this. Untitled.io server. Can I use it here in my place?
Yes, it's freely available. I mean.
Yeah. So no. So that's my question. It is free available. Now, when you map the data, so they push the data to this server, right? The file resource is stored in this server, right?
Yes.
No, so I mean, for example, no, you generated there. So can I see your resources here on my system here when I access this server? So can I check your resources?
No, I mean, the freely available thing is the software. So you need to take your computer, run it, and then the data is pushed to that instance. So here I do that. I run this file repository on my computer, and I put data on this instance. So this is my repository.
No, so you mean you can create the instance of this server, right, on your local machine?
I can create, yes, the resources on my.
So then instead of pushing the, pushing the resources to the public file server, they can push to your own local server, right?
Yes, to my local server. I'm pushing to my local.
Oh yeah, I mean, so that should, and that is easy or difficult to create. That is easy or difficult to create the local instance is easy or difficult.
I couldn't get the question, but it's up to you.
May I interrupt? Sorry.
Yeah.
This is Mert speaking from SRDC. It is easy to deploy since I am connected with my headphone. It is easier to understand here. It is actually easy to deploy both in local and also you can also deploy the server, deploy the OnFire to your server so that you can make it publicly available. So it is actually up to you.
No,
when you deploy it to your local system, you can reach it through the local host. But if you configure it in your server, it can be also available from outside.
No, I mean, for example, like if the professor said that I created the local instance, so that local instance, the data in that local instance should be only their data only. No one can push the data in their own instance, right? They can push the data to the public available, for example, parts, but the local instance, I mean, that is related to only this project, right?
Maybe it's better if we continue this in the chat or in an email before my colleagues with the other presentation.
Yeah.
Okay.
Okay.
Yeah. Maybe we couldn't understand what you're meaning, so maybe it's right. I will also respond in the chat. Am I canceling? You take over. What will we do? Okay.
Okay, thank you, Anil. Thank you for the participant for the discussion and the question. It's very useful for us. Now we are going to continue reviewing the functionalities that the FAIR4Health platform can offer to the scientific and research community. Please, Miriam.
Can I share my screen?
Yeah. But would you prefer to speak about this slide first, please?
Okay. No, just right to.
Or directly, would you like to share
the screen? Okay. Yes, if you don't mind. Meanwhile, Hello, everyone. It's me, Miriam. I hope you can see my screen and hear me properly. Thank you. I'm going to show you the portal we have into FAIR4Health to interact with the tools that Anil just show us, and the extension of the FAIR4Health platform. Here you have you can see all of you just using the URL, the portal. This is a public site or a web page, sorry, where you can see the sites and the use cases we are working at this moment. As you can see, we have 2 use cases in the identification of mortality related of mortality. And we have also developed and pilot and early prediction services for 30 days readmission risk. We have a total number of sites than 8 total number of sites and around 1,600 patients. We are working also with algorithms like FPROs and a few more. We want to include more algorithms. You can see also an access to our data model, and you can also contact from this screen with us to get. Sorry. Okay. This is the public site. You need some credentials to get into the platform. I'm going to okay, this is the private, because I'm already logged, didn't ask for username and password, but you need to have your credentials to get this, because this is the private section of this platform. Here you just need to select a use case to work with. Here we just select use case 2, which is a prospective study, early services for 30 days readmission risk. This wants to be, let's say, a wizard where the end user can go step by step into each section to setting up its algorithm and prediction. So for the first step, I'm going to get into, because we have already some details. Here the user can let's say defines variables and provide the FAIR. Let's see the details, some variables in here the user gives an FAIR query to indicate how the system will collect the data from the repository. Even if you don't have let's say knowledge of FAIR to make the search path, we have some already set it up for the end user in order to make this task easier. Once we have our feature set, second, let's say, more common step will be to set up the data set. In this section, take let's say eligibility criteria. It means, for example, I need patients older than 65 with diabetes and so on. Here we have some already created, where this is from IANS, and where the end user can see distribution of their data, and it also can see all the distribution by just clicking here. I'm going to be a bit faster because after Anil will go deeper in all those steps. let's say like the first steps will be to generate your model. In this section, I'm going to show the details. The user will following again like a sort of wizard by step, will select and define the algorithm to work with and its parameter. Here the platform inform the user and take some details. We go back always to the main menu, where from here the end user can make anything. And if we want to make a prediction, this is once we have our algorithm and parameter set it up, just to make the prediction. This from this portal, in these steps, it will be, we can do it patient by patient, or even having slotting a set of patients. Well, in this section, the user provides patient data. The patient data in relation with the variables and feature set that the user has defined, provide the data of the patient, and the prediction comes up. There are some predictions already done, and even the end user will see here some predictions. The prediction can be made by patients here, just by just including the details, or the prediction can be made by, let's say, a set of patients by including a file. I think that this is the description of the platform and everything you can do. And Anil, you're going to be.
Yeah, actually, I will show similar things, but I can talk more on the use cases.
Okay.
Can I share my screen, Alicia? Yeah. Okay. Thank you. So, okay, this is my screen. Now, I'm also logged into the FAIR4Health portal. So I showed you the verification tools. This means, okay, we have FAIR data on each clinical partner, but now what to do with it? We designed and implemented a federated system where we can execute machine learning some of the machine learning algorithms on this federated architecture, where the machine learning is actually runs in a federated manner on top of these FAIR repositories at each endpoint. So this is like, if you're familiar with tools, this is like a notebook, a Jupyter notebook. We can make a resemblance to a Jupyter notebook, but for this federated environment. A use case is like a project. So I create a use case. So let me just create the system demo use case. Demo use case. So while creating my use case, I need to say whether it's a prediction or association use case. So whether I'm going to look for the pattern associations on the data sets, or I'm going to build some predictive models. Let's make it a prediction. Save. So now I have a demonstration use case. I go in this use case, and then I can do a feature set management, data set management, model management, or prospective study in these use cases. So of course, this is going to be empty. If I want to create a new feature set, this means demo feature set. and I can add my features, my variables, by writing FAIR scripts. Since all the data, all FAIR data is now served by FAIR APIs, I can write, for example, for the gender. By the way, we have an automatic and manual thing. This means we already have some features, some variables installed into the system, like here, like gender, age, smoking status, and the variables. So gender means when I add this, you're going to see that empty fields. Yeah, I didn't give a name. Gender. Okay, you're going to see that that's a FAIR query and a FAIR path. Extract this data from the FAIR endpoints. So this can be done for each of your features and variables. And when you add them, but I'm not going to do that right now. Then I have a feature set. Then this means I can create a data set. Data set is something a different, has a little different in this federated environment. That's why I'm going to show it from an already available data set. Here you're going to see some data sets. There are two data sets created for this prediction use case. Let's look at one of them. This one. So this means I created a data set on top of a feature set by giving an eligibility criteria. And the eligibility criteria is again dictated by FAIR search and FAIR path scripts. So here I see that, for example, from each connected endpoint, I see some statistical measures, how this variable is distributed on these on this data set. For example, coming from SAS data set, I can look the minimum and maximum values and how much the what percentage of the data is null, empty, and if it's categorical, like like true, false, again the numbers here, and I can look at the all distributions here. So here, age distribution, gender distribution, these are automatically and dynamically created based on the feature set that I define on the system. And in the end, when I come to a model management, this means I can now build machine learning models selecting these data sets. For example, let's look at this one. So here, while executing some models, building some models, I can try different algorithms. Like here, I can see that I tried a random forest and decision trees. I can do this by giving different parameters. So these are specific parameters to these algorithms. People working with these algorithms know what these parameters mean. So I can, by also thinking about my data set, I can arrange these numbers and come up maybe looking at the recall and F measures. I can select the best algorithm, best model. And then this means now I can use these models for prediction services. That's the thing that we did for use case 2. The prediction algorithms showed by my colleague Miriam. We had some good predictive models, and then a prospective study has been carried so that to see whether we predict good or not. That was the idea behind this study. And the other use case was look for the association patterns on these distributed data sets. And I can say that so the prediction part is missing because we are not predicting anything, but the model is actually now showing us the associations between different variables and the data items in the data set. So the data mining model is ready. We see that the only algorithm right now we implemented for association is FP growth, frequent pattern growth algorithm in this federated manner. But for the predictions, we have more algorithms like 5 or 6, including the gradient trees and random forests and regression and support vector machines. So if I look at an example here, so here you're going to see that how these, so we have an antecedent and consequent, meaning that these items, these values are very related with this value, with this confidence, and with this lift. So these are some, again, some statistical measures to show how confident is the system about this association. We noticed that while running the use cases, most of the associations are the obvious ones, and the researchers were actually looking for non-obvious associations. So that required us to decrease the levels of the confidence and lift to very low values, and this created a huge requirement for hardware resources, because doing this, looking for these patterns is very processor consuming operations. But in the end, we had, I can say, correct results in terms of executing these algorithms in the federated environment. So that was all again from my side.
Thank you very much, Anil and Mer, for the description of the functionalities of the FAIR4Health platform. I don't know if you need to mention any details included in this slide.
That's like a summary of what we support on the system. We implemented the federated versions of these algorithms. I already said these list. And we have a flow like first defining the feature sets, then creating the distributed data sets. Then each agent prepares with respect to the feature set on top of the FAIR data that we created through the verification workflow. And then each agent trains a partial model on each deployment site, and these partial models are sent back to the manager, and there we create a boosted machine learning model to come up with these global models and predictions. That's the thing that we do actually.
Okay. At this moment, we need to say that that's all from our side. One of the aims of this demonstration was to share with you the functionality of our solution. But as you know, when we asked you to complete a form to be part of this session, we asked if would you like to start using the FAIR4Health solution to verify your own data sets during this session. We had 83 registered people in this session, and 12 of them expressed their interest to use the FAIR4Health solution today with us. In any case, we send an email with some requisites that we need to start working with us, with you. Sorry, we need if you would like to verify your own data, you need to install the on-file repository, the data curation tool, and we ask by email to share, if you would like to share with us the format of your own data set to start reviewing our solution and reviewing if it's possible. We expect it's possible, but to review the practical part of the demonstration. But only one person answered us, and I think she didn't complete the presentation. In any case, now we have, I think, more or less 40 people connected. I invite you to open your microphone to ask us questions, or if you agree, you could share. I can give you the role of presenter, and you can share your screen, open the data curation tool, and start this practical work. Any volunteer? We don't have volunteers to start working with us in the verification. Anyone had opened the micro? No.
Yeah, if no one else has a question, Kevin, actually, I'm intrigued about the explanation of this method of training partial models on distributed data sets and then bringing those partly trained models back and boosting or improving them centrally. I mean, this looks very attractive as a way of sharing data without actually having to exchange data. But I wonder to say more about the challenges of training those models and what might sometimes be relatively small data sets. So, you know, in some areas of health research, you only get the power when you bring lots of small collections of patient records together.
Yes, that's a, yeah. Sorry. Can I? Yeah. Is that okay now? Okay, sorry. So there are lots of microphones here. That's a very good comment, by the way. Thank you, Kevin. Indeed, that's one thing that we also observed. I mean, we can have the power of large data sets somewhere else, even if we have a very small data set on ourselves. And most of the time, this has a positive effect on the model, but sometimes it may affect negatively because my local data sets may have some very specific property, which I expect to continue to see in my models, but when I boost it with other partial models, it may disappear. But this is a very tiny thing, and this happens while training models. But thanks for just realizing the value of this federated approach.
Thank you. Any other question or any volunteer to work with us with the data curation tool? In this final slide, you have our contact details and the social network of FAIR4Health projects. Okay, thank you. We are going to share this recording in the YouTube of the project. Here you are the link. In the chat, Esther Thea Inau say, thank you so much for organizing this. I look forward to working with this tool, Best Wises. Esther, is very, it's a good new know that you and other researchers are interested in our solution and are interested to explore the possibility to use these tools, these open source tools, to work with this proposal, because our objective in the project was to extend the use of the FAIR principles in the health context. So thank you very much for the interest.
I think that Venkat wanted to say something, if I'm not wrong.
Yes.
Oh, yeah. Hi, everyone. Good to see you all. I'm glad I could make it, and thank you for that presentation. I'm glad things are, nearly finalized. I was just wondering about so not a technical question really, but more about the long-term sustainability of the tools. Please remind me what's being planned. So they're on GitHub, but with things like EOSC, what was the plan again? I can't quite remember. If it's going to be maintained, it's going to be put out for much wider use through EOSC as well. Is there some kind of plan there?
Maybe Anil, would you like to speak about the Work Package 6 outcomes? It's asking about future possibilities, if we are going to extend or not the tools.
Yeah, but maybe I thought that you were going to respond because the specific EOS question. Any case, well, we performed a business plan and exploitation roadmap with the Horizon Results Booster. We applied the methodology to only one tool. So, you know, we have a set of software systems here. But for individual tools, we have the long-term plans. Actually, we think that we even identified what's missing, and we also got that question here, one of them. Identified some points which can be improved, and maybe I think that this is open to other research projects also for future research projects. I think that both data curation and data privacy, or all this verification, can be improved and used. But for the PPDDM part, for this federated machine learning thing, I think the work is much more to make it happen because of these policy issues and connection issues with all the clinical institutes. We had some relation. We had a meeting with when we are talking about specifically EOSC. We had a meeting with their architecture group, and there was no follow-up until now. But it would be a good idea actually, and I think we should do it. We should pursue with this group on how maybe we can contribute even about our architecture vision to theirs, and maybe keep these tools alive by integrating into the EOSC ecosystem. We have those plans, but I think they are going to be realized in the long run.
Thank you, Anil. Venkat, from the coordination of the projects, I can start reflecting about future steps. In my opinion, with FAIR4Health, we have learned a lot about open science, about the use of the FAIR principles, about the advantage that we can have if we share the metadata or to the data. From my research group, I'm sure that we are going to continue working in this kind of topics Obviously, we are a research group and we are continue trying to catch fundings in this sense. I'm not sure if Carlos Parra would like to add some details.
Hi, Venkat. Nice to see you.
You're here.
The project finalized now, and the agreement with the European Commission finalized now. But in any case, we have the interest about some kind of sustainability. The software is in GitHub. We have some metadata published, and we also will continue our activity in Research Data Alliance, and we can announce we will present to create a new working group in European Federation for Medical Informatics related to FAIR principles. Will be very soon, because the council of this federation will be next Friday, and this kind of activities are now we can offer to the community. In any case, we or the consortium has the interest. All the partners and the consortium as a whole has the interest to continue the activity, and we try to explore how can fund our work to improve the tools, to support and offer services to the community to use.
Okay, thank you very much, Carlos.
Thanks, Carlos. Thank you.
Okay. If we don't have more questions or more comments, I only would like to thank for all the participants in this session. It's very important for us and for the projects know that the scientific community is interested in these topics that we covered with the FAIR4Health projects. We really invite you to explore the tools to use the open source developed in the project. We are available, and you can contact with us if you are interested to collaborate with us in the future. And Carlos is going to add.
Sorry, other comment related. We will, for the FAIR4Health open community, we will send information about the possibility to collaborate with this potential new FME FAIR data working group, because previously this working group must be and with the decision of the Council of FME, and we will use the open community to recruit some researchers with interest to collaborate in this working group, because also that is an open community to very with coordination, of course, with Research Data Alliance, like must be. Okay.
Okay, so on behalf of the FAIR4Health consortium, I would like to thank you for the participation, and we hope to collaborate with you in the future. Thank you very much.